Hello.
Hey, how's it going?
Good morning, good evening, good afternoon, wherever you are in the world. Thanks for tuning in. This is the first of a series we're calling Dylibso Insiders. Just a place for us to get to share a little sneak peek behind the scenes, behind the curtains of what we're working on. It could be some cool internal thing that we haven't released yet and want to get some feedback on. Could be an open source project that we're working on. In this case, today we have our esteemed CTO, Ben Eckel, to share with us about the Chicory project, which it falls under the category of an open source project that we work on. And excited to hear the latest and greatest, kind of how the origin of the project came to be, where we're heading with it, why we're doing it, and what you can expect from Chicory in 2024 and beyond. Hey there, Stefan. Nice to see you. Thanks for tuning in. Folks, please feel free to drop comments throughout. We'll take time to answer questions and chat with you on stream. Ben has a presentation for us, which I'm looking forward to. Ben, feel free to take it away whenever you feel like it.
Sure. Is my screen visible now? Let's see. Looks like we have full screen here on the presentation.
Yep.
Great. Okay, cool. Yeah, I'm just gonna go through a little presentation and should be pretty casual, and we'll probably also have a little discussion after. But what I wanted to talk about is sort of what is Chicory, talk a little bit about the history of it and why we created it and how. And I also want to take some time to talk about the progress we've made and the future. So let's get it started. So Chicory started in earnest, I think, back in, early 2023. So this was shortly after we had started Dylibso. And, I was in a period of really wanting to explore WASM a little bit deeper, wanting to have a better understanding of how it works. And I've always had this feeling of, needing to kind of code something to understand how it works. So what I did was I basically took this simple WASM module and I wrote in JavaScript a parser and little runtime that ran this one module. And that kind of forced me to go through and learn to read the specs and to kind of get just a little bit more intimately familiar with WebAssembly. And I actually really enjoyed it so much that I just kind of turned it into an onboarding process thing that all of our employees do. So when you join the company, you learn to parse and run WebAssembly right away. And it just kind of gets people familiar with how to read the spec, sort of the nitty-gritty details of WebAssembly, all that kind of stuff. So yeah, I did this and, it kind of scratched the itch, but of course I really wanted to go deeper and never really found the time or opportunity to do so. So this kind of just sat in the back of my mind of like, oh, maybe one day I'll write a runtime. Then shortly after that, we had started experimenting with a runtime called WA0 by the Tetrate team. And what this is it's a WebAssembly runtime that's specifically designed to be embedded into Golang applications. And this sort of got me thinking about a few things. Just in general, the possibility that you could make a runtime just for a language just really started to get my mind thinking about why you would do that and why it's interesting. We started using it, really loving it, and getting to know the team. And that was kind of step 2 of the creation of Chicory. So, what happened around, I think it was around spring of 2023, I sprained my ankle and I had a little more time and I thought, okay, now would be a time. I have some weekends where I'm just sitting on the couch to kind of expand on my WASM Kata idea and actually kind of build out more of a runtime. But I had just sort of chosen JavaScript as sort of a pedagogical thing just to kind of make it simple. And I was thinking like, if I'm going to spend the time to build a runtime, I should try and do something that actually has like real value in the sense that, with Node or JavaScript or the browser, you already have a WebAssembly runtime embedded, right? So there's not really a real, business reason or infrastructure reason to build a pure JavaScript WebAssembly runtime. Well, there's a few small reasons, but nothing like big, right? So I started thinking about what language could really use something like this. And I kind of keyed in on Java for a number of reasons. So first off, we have Java users of XDism who are running WebAssembly in their Java applications and using XDism to extend it. And we use, the WasmTime runtime, and it's native code. And people were just having a lot of trouble just running WebAssembly in Java for a variety of reasons. And I noticed that talking to a lot of people who are using this library, which the use was a lot higher than I thought it would be, that they just were saying, hey, like this just ended up being the easiest way to run WebAssembly in Java. And that kind of really got me thinking about like, like, okay, there's a need here to be able to make running WebAssembly in Java easier. I think the other thing is Java is just like a huge ecosystem. At Dylibso, like the main thing we're interested in with WebAssembly is essentially like unlocking the value of existing applications, right? Like, and there's really no more value than the JVM. I mean, in terms of applications, right? There's so much out there, and bringing WebAssembly to this ecosystem, I think, could unlock a lot of opportunity and value for people. This is a slide from one of my talks that I'll be talking about a little bit later. So let's take a step back. There's kind of two ways that people have been like doing WASM stuff lately, right? So you might kind of see people talking about WASM in this way a lot, which is sort of like you take your application, you compile it to WASM, and you ship it off to some platform that runs WebAssembly. And this is like a very natural way to understand it, because if you think of WASM like the JVM or something, this is kind of what you're doing, right? You're running your application, you're shipping it off to some generic runtime to run your application. This has never really been our interest at Dylibso. For us, it's more about embedding WASM in existing applications, not porting your application to WASM, right? So our patterns of distribution typically look something like this. We have a library or some kind of plugin, and we're compiling it to WASM, and then we're embedding it inside of an application in a different language, right? So for Java, you have your Java application, and you're running this plugin or this library in native code and WasmTime. We're using FFI, dynamic linking, that kind of stuff, right? So we think this is like really valuable, but it kind of causes some problems because you have this situation where you have these two runtimes kind of fighting. Like you have to embed one runtime in another, and there's all sorts of issues with that. I go into a lot of detail in this in our WasmIO talk from March of this year that you can find online. You could just Google WasmIO and Chicory and search for YouTube. And the main kind of thing with like running native code this way in Java and having this native WebAssembly runtime is basically like, yes, it can be fast. You have a lot of options like WasmTime, but there's really two major cons. One, on a distribution level, you now have to kind of distribute this native object everywhere you want to run your application or your library. And, there's just like, that kind of destroys the purpose of writing in Java or Python or whatever you're writing. And then there's also at runtime, there's all these FFI issues where there's performance and kind of safety issues. You're having to, because you have two runtimes, you're having to escape your native runtime, your Java or your Python, and then going into this WebAssembly runtime and coming back and forth. Lots of issues with that as well. So what I sat back and envisioned was, and not, I'm not the first person to envision this. Probably Waziro is the pioneer of this, but I sat back and I just envisioned this idea of a language native runtime, right? Like what if WebAssembly could just natively be run in the environment that your language supports? So this is sort of the simplified version of all this, right? Where you have a library or plugin, and you put it into Chicory, and then you just basically get a jar that comes out of it. And it has that WASM as well as just some Java code, but there's no native code. This just is normal JVM code, and it should run anywhere the JVM runs.
Ben, can I jump in and ask a quick question?
Yeah, of course. Yeah, thank you.
I love a phrase you use often to talk about WebAssembly inside of a language native runtime, like for example V8 and the WebAssembly engine there, that when you have a language native runtime inside of your runtime, you kind of have this sleeping giant, as you like to say it, and it's just like this little bit of like a superpower that's embedded inside the existing language runtime, ready for you to take advantage of it, or ready for somebody else to take advantage of this. And for all intents and purposes, like anytime you have to embed a runtime inside of the language runtime, you kind of miss out on that opportunity. So JavaScript, there's a really great story there. It's amazing. WAS0 being able to be embedded into Go natively, WASM time into Rust, WASM Edge into a C++ program. There's great options, but Java had just been left out of that story, except for a couple attempts, and one I think leading from Oracle called GraalVM. But the benefit being able to take in any JDK, run Chicory, and now you have this native language runtime inside of your Java app is pretty huge. So I just wanted to underline that a little bit here.
Yeah, it's a great point. I would encourage people to go look at about this kind of sleeping giant idea, which I should probably write more about. I should encourage people to go look at something I saw recently, the Llama TTF thing, or the Llama font, which is just an interesting example of if you have a WebAssembly runtime hidden in your application, it can do a lot of really interesting things. It can make your application way more flexible. And that was an example of just someone by accident finding a WebAssembly runtime in their applications. But what if you did it on purpose, right? What if it was part of the programming language? So that's kind of what we're trying to get at.
Yeah. I dropped a link in the chat for anybody who's interested. Pretty wild. You.
Cool. Yeah, so let's continue. So I had this vision, and it might seem kind of insane. And I guess it was a little bit insane. I remember talking to you guys about it, and you were like, what? But we're also really excited and curious. So let me just kind of talk about the steps that I did. So first thing I had to do was basically, parse the WASM module. So I just, started with writing some Java to sort of completely parse a module. Being able to parse all the types, all the sections. In the WASM kata, you really only need to parse like a little bit of it to kind of get it to work. You don't really need to, there's really not much to it, but I had to build like a complete parser, which actually wasn't too bad. And the specs made it, there were some issues, but for the most part, I was able to do it pretty quickly. After that, we have to execute this. And the simplest way I could think to do it is just a bytecode interpreter, right? So Chicory today, the interpreter looks kind of similar to this. That hasn't changed much, but this was some code from early on when I got it working. And you can just imagine it's like a big while loop with a switch statement, just kind of churning through the bytes and interpreting the opcodes and manipulating the stack. So it's just a straightforward interpreter. And I wrote this up pretty quick and got it. Not a complete implementation, but enough to kind of do some simple things. So first thing I did was I was really interested in running, WebAssembly on Android for a lot of reasons, because the story about flexibility there on mobile phones is not very good. So the first thing I did was I just tried to compile our canonical count vowels WebAssembly module, which just counts the vowels of some text that gets passed to it. And I wrote that in Rust, and then I compiled it to WASM, and then I got Chicory to run it. So this is an example of that. Oops. And this is in the the Android emulator here. And you'll see as I'm typing, it's counting the vowels. And it's pretty quick, even at this stage, like even when we just kind of first built it. As long as the modules are small, it can do this quite quickly. And I got to this point, and that's when I was sort of like, okay, this can be real. I want to take this further. So the next thing I wanted to do was like, okay, this thing just couldn't run any WebAssembly module, right? Even compiling from Rust, I was sort of running into some issues. So I needed to build a robust test suite to get to build a fully compliant system. So I looked at, the WebAssembly test suite for this, which is a open source repo. And it's got a bunch of WAST files, which are kind of like WAT files, but you can do assertions in them. And people use this to sort of, test the validity of their runtime. So the way that I did this was I just wrote a Ruby script that parsed this and then generated JUnit test. And I started working on this, and I was getting some good results, but things were like not looking great. Just like the Ruby code, and like it was very hacky. And I was starting to feel like, okay, like in order to really like do all this, and like, yeah, I was seeing all these failures, and I was like, that's going to take a long time to do all this. So I started reaching out for help, right? I was like, okay, how do we find some people to help us out? Who's going to help us kind of build this? And, you know, I started reaching out to a lot of the places and the WebAssembly discords and stuff, and people were saying, you're an idiot, you're insane. So it's really difficult to find help. But then I talked to a guy, Eduardo at Waziro, and he introduced me to Andrea at Red Hat. And Andrea got it immediately, and he was like, this is awesome. I want to work on it. And with Andrea's help, he came in and really just sort of rewrote this like test suite stuff in Java and made it really nice. And we were able to generate all the tests and start getting a bunch of tests passing. We were getting tens of thousands of tests passing. So he really came in and kind of helped like make it real, and get to the point to where we have like a pretty compliant runtime. And actually, we're now at a point where we're passing all of the normal WebAssembly test suite specs. So yeah, shortly after that, Andrea hooked up llama.c to Chicory, and I sped this up a little bit, so I don't want to give the impression that it's this fast, because you know it's still in interpreter mode, and this was kind of still early on. But he was able to get an LLM to start, hallucinating stories. So it's like that was pretty cool. That was an interesting moment where we realized like, okay, all of our work on getting the specs to pass has made it so we can kind of compile more complicated things to run on Chicory rather than just count vowels or whatever. And then we also canonically you got to get Doom running. So Andrea did that, and with the help of Thomas Deramont came on and got it working a little bit faster. So we now have Doom running in the interpreter mode. But yeah, it's still a little bit slow at this point. But we've kind of proven like, hey, this is like working. It's not crashing. We can compile random software to Chicory and it works. And starting to look at kind of next steps, right? So I always sort of envisioned like we wanted to make this very simple, straightforward interpreter. But my vision was that WebAssembly, it should be compiled to JVM bytecode to be run. Like that's the way that we actually turn it into something that is not just an experimental thing or used for limited environments, but something that actually could be run in a production setting at speed and actually be competitive with other WASM runtimes. So this might sound insane, but it's actually like pretty straightforward. So the idea is we take our WASM code and we compile it to JVM bytecode. And that's really all we need to do, right? So like when I say we're writing a compiler, I think a lot of times people get it in their head of like, okay, I need to, emit code. I need to like emit code for these different architectures. I need to do optimization passes. I need to worry about security and all these kind of things. The nice thing is the JVM takes care of all that stuff for us, right? So all we need to do is kind of get this to bytecode, and the JVM will take care of most of the rest, right? And another nice thing is that WASM and the JVM are semantically very similar, right? They're both stack machines. They're both like relatively small bytecode, a number of opcodes. It's not too hard to port or to compile WebAssembly code to Java bytecode. There's certainly some tricks that need to be done, but it's not as crazy as you think, right? So in the back of my mind, I always had this as something we do, and we finally got started on it. And we're using a project called ASM, which is an older project in the Java world that's been around for a long time. And this is just basically a way to write some Java code that emits Java bytecode and run it. And it's used, throughout the Java ecosystem. So it's pretty standard thing. So two of our contributors, Daniel and David, had started on this just a few months ago. And they did a really good job of creating an architecture that shares a lot of implementation between the interpreter and the compiler, right? So one of the nice things that we do is a lot of the logic of the runtime is in these sort of static methods that can be shared amongst both implementations. So we can go and like generate more optimized bytecode for some of those implementations, but to bootstrap the compiler, we basically can just proxy method call all of those static methods. And we've actually got to the point to where here it's called AOT. So the AOT compiler is catching up to the interpreter in terms of test passing. And we haven't really done any like real benchmarking yet, but this was in a PR that landed last week for implementing control flow, which finally gave us the ability to sort of run our benchmark, our small benchmark of a factorial function. And we can see that we're already seeing in throughput like 2 orders of magnitude increase in speed. So it's pretty promising that, you know, it's at least going to be, it'll start off being fast enough to, you know, probably be usable for production pretty soon. Okay, so that's it. I'm going to just talk a little bit about, you know, where we're going next and everything else. So our roadmap, basically the goal of last year was just to bootstrap this thing, get the test running, and we did that, and all of that's passed. And this year we're focused on over the summer, just making the interpreter and the API production ready. So kind of aiming for like a 1.0 beta release where we kind of feel somewhat stable about the API. We're also working on the make it fast roadmap item, which is the compiler, which is going a lot faster than I thought it would. So that's coming along. And then finally, there's make it compatible, which is like a lot of the specs. We have WASI P1 support, and we also have hooked up the WASI test suite, but we have roughly less than half of WASI P1 implemented. So we would like to kind of add some more and would love like contributions there. And finally, like just wanted to call out, like this is certainly not our company like doing all this. In fact, like I'm struggling to keep up with the community. Like there's really so many different people who've been coming along and really making their mark on this. So I wanted to take a moment to thank everyone, as well as give you guys an opportunity and call out. And also, if there's anything that any of you listeners are interested in working on, like come join our Zulip and talk to us. Like we're always looking to grow the team and you know, work on the next steps here.
That's awesome. This is a super exciting project, and I wanted to also highlight one of a concrete use case that I was pretty excited to see just kind of emerge, where the JRuby project is leveraging Chicory to kind of create a more consistent parsing story for Ruby code in the JVM. Would you touch on that just a bit?
Yeah, sure. Yeah, so yeah, I actually should have probably spent a little more time talking about how people are using it. Let me show this project called Prism. You can see my browser here, right?
Yes.
So Prism is like an attempt to remove the Ruby parser or decouple it from all the rest of the Ruby code into a pure dependency-less C library, so that the Ruby parser is more portable. And parsing Ruby code is like kind of complicated. So it's one of those things where it's like quite difficult to port to other languages. And one of the big platforms that Ruby has is JRuby, which is a Ruby implementation on Java. So instead of them having to like constantly just port changes over to Java, they want to be able to just run that C code directly. So how do you do that? You know, there's the whole native linking story, which we sort of talked about before. The ideal way to do it would be compile that Ruby parser to WASM. And then you can just always have an up-to-date parser, and you can run it in your JVM application or in your JRuby. So what the JRuby team did is they came along and really early on and compiled Prism to WASM and started using it as kind of the base case for parsing Ruby parsing modern Ruby syntax in JRuby when there isn't the capability of like doing it natively. So as of right now, like there are situations where to kind of bootstrap JRuby, they will use Chicory to run that Ruby parser. And we've kind of talked about too, like it's still like they were saying it's about 6x is slower than C, but that's the interpreter, right? So now that we're working on the compiler, we want to go back to JRuby and talk to them about other possibilities about how to kind of share more Ruby code inside of the JRuby, or sorry, share more C code inside of the JRuby ecosystem so that they're not having to port or run native code as much. They can just kind of compile it over to WASM and bring it in to the JRuby platform.
It's pretty incredible. And like, even if you just take the rough, throughput numbers on the benches that were done against the interpreter and AOT compiler, it's theoretically possible for the JVM to incrementally optimize JVM bytecode to become faster than C. So we could even surpass that C benchmark of the Prism parser in straight C parsing Ruby code. And I think like this is such a great example of why WASM is so powerful, where like the work necessary to parse Ruby in Java and keep it compliant with the core spec, in C is just a really, really challenging amount of work to do. And like to be able to save that and use those resources and that mental energy on something else is just like a incredible win. So to see this kind of impact in projects like JRuby and elsewhere is really inspiring. And so I'm really proud of the work so far and thankful for you and everybody involved for contributing so much time and effort to it. I'm excited to see WASM and Java really kind of coexist in a meaningful way.
Yeah, I do agree. I would love to go back to the team and figure out some more benchmarks, and I guess we'll see. But I do also we do kind of have a theory that in some ways this could be faster than native code, mostly just because of the overhead of FFI, and also the fact that like once you leave the JVM, it has no ability to sort of like optimize that code or control it in any way. So it could be a better experience, like a better developer experience, as well as even potentially some performance benefits to doing things this way, which again, that's theoretical. I want to go like actually try that. I think JRuby would be a great case to try it. Because that's a real like, complicated C program, the Ruby parser. But yeah, we'll come back and share our results once we do that.
That's awesome. One other question for me, and again, if anybody has a question, please feel free to ask. We have to jump in just about a minute here. But given the history of the JVM and all of the optimizations built in over the last 30 years and into the variety of different compilers, I'm curious if there's a path to do WASM optimization through the JVM for other runtimes too. So like take my WASM, use Chicory to AOT compile it, run it inside of JVM in kind of a warm-up phase, get some optimized native code, and if we could back that into WASM as potentially optimized instructions, could we benefit other runtimes to taking advantage of WASM optimized by the JVM, kind of reversing, like flipping the story from taking WASM to JVM bytecode.
I don't know. That's an interesting idea. I definitely think we have some people who could think about that and experiment with it. One thing I'm particularly excited about is like this idea of like bringing other JVM things, like for instance, with the GC spec, once we implement GC, in theory, you'll be able to say, run some Python code and use Java's GC. Like those kind of things will be really interesting once we're kind of sharing pieces of the JVM with guest code. But this is all fairly theoretical at the moment. And I do think it's all possible, but yeah, it's, if anyone wants to come try any of these things, come let me know. I'm happy to help you. But there's a lot of just like, there's just too many exciting like ideas to try out. So
definitely.
I'm probably not going to be the one to do all of them. I'll do one or two of them.
Well, we are at time. Thank you, everybody, for joining. I've dropped a link to Chicory in the show notes. If you want to join the project, get involved, there's a link to the Zulip chat community on that README. There's an incredible team working on all of this. You'd be very welcomed to join. Somebody will help you get up to speed. There are issues to pick up, and there's plenty more to be planned. So if you're interested in a particular spec to be implemented, like WASM-GC or Threads or something, let us know. We want to do them all. It's just a matter of timing and priority. So please make some noise. Come join us. It's been a lot of fun so far. There's still a lot to do, but Chicory is already really kind of ready to start experimenting with and using in earnest. So check it out. Let us know what you think. Thanks again, and we'll see you next time around. Thanks, Ben.
All right. Thanks, everyone. Bye.
Bye.